Section 1.3 deals with writing algebraic expressions. The ultimate goal here is to translate verbal phrases into expressions by identifying key words and phrases. There are certain keywords out there that mean different mathematical operations. For example, some that you're familiar with might be sum or plus for addition, difference for subtraction, or product or times for multiplication, and quotient for division. A few that I want to stress, particularly ones that you either see in the real world frequently or might cause a little bit of trouble, are total would be a word that you would see that would mean to add. Less than means to subtract, and the reason I'm going to star this one is because it actually means to subtract in the opposite order. So for example, I'm just going to show you an example up here. If I said 3 less than 9, you know that that answer is 6. And to get there, you actually do 9 minus 3. So when the keyword or phrase is less than, the person that comes first goes second, the number that comes second goes first. A few other keywords and phrases that would be notable are of for multiplication, and that's an of when it's all by itself, because you'll hear sum of, total of, difference of. But when of is all by itself, it would be multiplication, and often you'll see that with percent problems. Other words that mean multiplication in the real world would be per or each. So for example, jeans cost $10 each. You would multiply the number of jeans by 10, or you might hear $10 per pair. Another one that frequently gets confused is twice. So if you think of your age and then someone twice your age, you probably just multiplied by 2. So now that we've talked about some of the words, we'll talk about how to actually approach these types of problems. The first couple are very simple and straightforward. The first thing I do is I just scan through the problem and I look for a keyword or phrase, and if I find one, I underline it. So here I see more than. I know that more than means to add, so just 5 plus x. As I'm scanning through this problem, the keyword or phrase that I see is product. Product means to multiply, so I would write 3y. I put the middle dot just kind of as a reminder, but I can also just put 3y just back to back like that, and that's actually a little bit better just because it's a little cleaner. On the next problem, I see difference. I know difference means to subtract, and I'm subtracting 7 and b. Less, keep in mind it's not less than. Less would just mean to subtract in the same order. And then here's an example, less than. Less than means to subtract, but it means to go opposite order. So on this slide, we're going to talk about writing expressions when you see more than one keyword or phrase. Just to preview with the second example, you see more than, that's your first keyword or phrase, and then you see times. So one rule that we're going to follow is anytime you see a second keyword or phrase, you're going to always use parentheses around that second keyword or phrase. So the first keyword or phrase that we see is more than. We know that means to add, 4 plus. As soon as you get to the second one of times, I'm going to open up parentheses. And then I look at the things that I'm timesing, 6 and n. Now because of order of operations here, you would do the multiplication of 6 and n first because of the parentheses, and then you would add. And even if the parentheses weren't there, you would still multiply first because multiplication comes before addition. But it's just a safe habit to get into, to use the parentheses, because they'll never hurt you to have them there, but sometimes it could hurt to not. So you're going to pause the video and do these 1, 2, 3, 4, 5, 6, 7 examples. And anytime you see a second keyword or phrase, get in the habit of using parentheses. Pause the video when you're ready, and then press play to check your answers. So even though on all of these examples, the parentheses may or may not change the problem, I put them in all of them so you can see that they would where they should go. Difference, subtract, product of 5 and x. Product was our second set, so that's why there's parentheses there. Again, if you took it away, it would be okay. Remember on this example right here that less than means to do -7, less than means to reverse the order, and twice means to multiply by 2. Squaring a number is asking you to use that exponent. Quotient, we're going to start to show division by using a fraction bar. Here's an example of one that if you didn't have the parentheses, it actually would change the problem. So times is your first keyword, and the multiplication's happening right there. Sum of 4 and a number. I just made up x for my number. If the parentheses weren't there and it said 8 times 4 plus x, when you follow order of operations, you would multiply before you add. So that's why the parentheses are really important. 12 decreased by a number x, and the quotient of the square of a number m and 5. So in this first example, we have a piece of ribbon that is 8 feet long. And we're cutting off this piece right here, which is L feet long. The best way to come up with this, if it doesn't come naturally to you, is to make up a number for L, because L is your variable, so make up a number that might make sense. So if you have a ribbon that's 8 feet long, maybe you're going to cut off 2 feet. So you would do 8 minus 2 and get 6. But you don't always have to cut off 2 feet. Maybe you want to cut off 3 feet, and you know that would leave you with 5. Or maybe you want to cut off 4 feet, and that would leave you with 4. So if you look at your 3 problems that you set up, one of these items never changes, and it's your 8. And that's because you're always starting with that 8 feet of ribbon. But the thing that's changing is the piece that you're cutting off. So you could cut off 2, you could cut off 3, you could cut off 4. The bottom line is that it's changing or varying, so instead of using 2, 3, or 4, we're going to use L. Expression, 8 minus L. You're going to try the 2 down here on your own, and when you're ready, pause the video. When you're ready to check your answers, come back and press play. So at this point, you have an answer for the amount of tips each person would receive. So hopefully you have an answer kind of somewhere in here, and I don't know what it says, but it probably says something either with a 5 or a 6 and a variable. And I want you to imagine, what if the amount of money in the jar was $30? How much would each person get? Well, since it's you and 5 other people, that's 6 people total, and since there's $30, you would each get $5. Don't forget that there's 6 of you and 5 other people. So you know that if there's $30 in here, everyone would get 5. So what you're going to do, whatever your answer says here, or whatever your answer might be, take your variable and change it to 30. If you change your variable to 30 and do the math that you have said to do, will it come out to 5? If it does, you've done the problem right. If not, you need to rewrite. So the question is, we know we're going to divide by 6. We divided 30 by 6 because that was the amount of tips. But maybe there's not $30 in the jar. And since it can change, that's our variable, x over 6. Down here, I tried to trick you again. You and 4 friends, that's 5 people. And if you're each ordering the nightly special, the thing we don't know, we'll let our variable represent the cost of the nightly special. And you can even think, well, if that was $10 and there's 5 people, that would be $50. So the quick way to do that is to multiply. Up here, I meant to mention, x stands for the total amount of tips. Rates and unit rates. So if you remember from last year, a rate is a comparison of 2 quantities with different units. So that would be like comparing miles and hours. And a unit rate is when a rate has a denominator of 1. So in the first example, it says that the car travels 110 miles in 2 hours. So the thing that we want to know is, how many miles can it travel in 1 hour? And since we want that 1 to be part of the denominator, I'm going to put 1 hour here. That's my objective, is to get there. But they give me 2 hours to start with. And I'm going to put on top of that 110 miles. And so then to make a 2 into a 1, I divide by 2. But with fractions, whatever you do on the bottom, you have to do it on the top. So So 110 miles in 2 hours would have a unit rate of 55 miles per 1 hour. It's really important when dealing with unit rates that you keep your units there, because if they weren't there and it just said 55 over 1, you don't know what's being described. So the units are an extremely important part of unit rates. So for the two examples here, you're going to set up a unit rate, and on the first one, you're going to want to know the cost for 1 ounce. And on the second one, you're going to want to know the cost for 1 gallon. So make sure you're going to pause the video and set up your fractions appropriately and find those unit rates. So since on this example we want to know for 1 ounce, and in a unit rate, the unit 1 shows up in the denominator, I put ounces on the bottom, and we started with 16 ounces for $2.99. To make the 16 into a 1, you divide by 16, which means you're also going to divide the top by 16. On a calculator, it came out to 0.186, which would be almost 19 cents, and that's my unit of dollars, my unit of ounces. On the second one, 1 gallon, so I start with 9 gallons on the bottom for $29.70, divide top and bottom by 9, $3.30 per gallon.
So in this first example, it says that your basic monthly charge for cell phone service is $30, which includes the first 300 minutes. So whether you use 0 minutes, 100 minutes, 200 minutes, 300 minutes, you're going to pay $30 no matter what. And then after that, you pay a fee for each extra minute you used. And 1 month, you paid $3.75 for 15 extra minutes. So the first thing we're being asked to do is write an expression to represent the total cost for your monthly bill for any number of extra minutes, because right now we only know our total cost if we have 30 extra minutes. So the first thing that we know is that we're going to pay, no matter what, we're going to pay that $30, because that's our base fee. It costs $30 for up to 300 minutes. And then after that, it's going to go up. Here's where it gets tricky. So we need to know how much it costs per extra minute, but all we know is that it costs $3.75 for 15 extra minutes. Our variable, x, the thing that can change, is going to be the number of extra minutes, and what we need to know is how much do those extra minutes cost. So we're going to make a unit rate, because we want to know the cost for 1 minute, and we know it's $3.75 for 15 minutes, and since we want to know for the cost for 1 minute, that's 15 goes on the bottom, and then we're just going to divide top and bottom by 15. And if you do that, you end up with a cost of 25 cents per minute. So if we go back to our original expression over here, where we know it's $30 plus, since it's 25 cents per extra minute, and x is the number of extra minutes, we would multiply however many extra minutes we use by the cost, which is 25 cents, add 30, and that's our expression. And now to find the total bill, if you use 22 extra minutes, we just take our expression, 30 plus 0.25x, but now we know that the number of extra minutes is 22. Follow order of operations. So that gets us 30 plus 550, because that's 25 cents times 22, which would be a total cost of $35.50. So you're going to try the ski problem down here on your own, and it's very similar to the minutes problem up here. You know that it's $40 per month, and then you pay, that includes 10 lift tickets, but after 10 you would pay a fee for each lift ticket used, which is what you don't know. So you need to use this information to figure out the cost for 1 lift ticket, and then write the expression to represent any number of lift tickets, and then find the total cost if you bought 7 extra lift tickets. Pause the video, press play when you're ready to check your answer. So our unknown in this problem would be the number of extra lift tickets, so that's our x, and we know that it costs $13.50 for 3 tickets, but we want to know the cost for 1 ticket, so we set up our rate and make it into a unit rate by dividing top and bottom by 3, and we get that it costs $4.50 per extra lift ticket. We have to pay the $40 no matter what, and then add to that $4.50 per extra lift ticket, so 40 plus 4.5x. That's our expression. And now we know that the number of extra lift tickets is going to be 7. 4.5 times 7 is $31.50 for a total cost of $71.50.